Hello everyone. Today we're taking a look at the review stations for the polynomials unit. Since this test is coming up for us soon, we want to be ready. So let's take a look at station 1. Station 1 says use long division in each case. And the first problem says 4x to the third minus 8x squared plus x plus 3 is all to be divided by 2x minus 3. So let's put that 2x minus 3 outside. And 4x to the third minus 8x squared plus x plus 3. What do I have to multiply this to turn it into that? Well, x to be x third, I need an x squared. And 2 to become a 4, I need a 2. So I'm going to have 4x to the third, and then when I distribute this to this, minus 6x squared. Don't forget, with long division, we subtract. And so we're going to have minus 2x squared, and bring down that plus x. What do I multiply this by to turn it into this? Well, that looks like a negative x to me. We've already got the 2. We have one of the x's. We need the extra x, and we need the minus. So when I distribute back, I'm going to have negative 2x squared plus 3x. And I'm subtracting. So 1x minus 3x is negative 2x. And don't forget to bring down plus 3. If I multiply by a negative 1, I'm going to get negative 2x plus 3 with a remainder of 0. So there's my long division. This is the result of doing the long division. That's called the quotient. Second question here, part B, gives us a fourth degree polynomial, but we're dividing with a second degree polynomial. Remember, with all these division problems, look out for a 0 placeholder. No one's going to tell you you need one there. You're just going to have to say, oh look, plus 0. So what do I multiply this by to turn it into this? A 4x squared. And then I'll distribute that 4x squared to each of these things. 4x to the fourth plus 12x to the third plus 8x squared. Remember, with long division, we subtract. 6x to the third minus 12x to the third is going to be negative 6x to the third. 11x squared minus 8x squared is 3x squared. And let's bring down that 6x. So what do I multiply this by to turn it into this? Well, I'm thinking I need a negative 6x, because that's x to the third. And so I distribute that negative 6x back. Minus 18x squared minus 12x. And I'm going to subtract. 3 minus a minus 18 is 21. And 6 minus a minus 12 is positive 18. Finally, what am I multiplying this by to turn it into that? 21. So I've got 21x squared plus 63x plus 42. And don't forget we're subtracting. So 18 minus 63, yeah, I'm definitely going to want to do 18 minus 63 with a calculator at this time of day. I end up with negative 45x minus 42. And so we could say 4x squared minus 6x plus 21 plus negative 45x minus 42 over our divisor x squared plus 3x plus 2. Alright, that's station 1. Just a little reminder of long division. How about station 2? Ooh, use synthetic substitution to find each of the given. So f of x, x to the third plus 0x squared minus 13x plus 10. Again, don't forget the 0 placeholder. Next, even though I've used the capital words here, synthetic substitution, when I ask for f of 1, most students don't use the synthetic substitution asked for. They plug in that 1. And get an answer that way. And if you do that on our test, I'm going to have to mark it wrong if the directions say use synthetic substitution. So 1, 4, 0, negative 13, 10. of 9, 1. So, how do I understand this? Well, I understand that f of 1 equals 1. That's what we learned from the remainder theorem. We can use synthetic substitution to evaluate expressions. And I noticed that we're going to have to do this a couple more times. Second time, we're doing it with -2. 4, -8, -8, 16, 3, -6, 4. And so I know that f of -2 is going to be 4 by the remainder theorem. It's pretty fast, especially when I come to something like 1/2. I don't want to put 1/2s into those places. So I bring down that 4. 4 times 1/2 is 2. 2 times 1/2 is 1. That's a 13. Minus 13 plus 1 is minus 12. And then I get -6 and 4. F of 1/2 equals 4. I tell you, even with fractions, no problem. Then explain what the remainder theorem is and what it has to do with the problems you just did. Well, that's great. We knew that. The remainder is the y value goes along with the ordered pair for this x value that you're inputting. The remainder is always giving us the y value of the function at that point. Okay, that was station 2. Station 3. Factor each polynomial completely, knowing a given root. So our first one here says f of x equals x to the third plus 2x squared minus 6x. No, 3x minus 6. Now it says factor. It does give us a root, so I suspect I'm supposed to do something like root 3, 1, 2, -3, -6. 3, and we're adding. And when we distribute this to this, we get 2 root 3. And when we distribute this to this, we get positive 3. So look, -3 plus 3, they cancel. And we have 2 root 3. Finally, I multiply this times this. Root 3 times root 3 is 3. 3 times 2 is positive 6. And so we get our 0 just like we expected. Well, that's great. But now we need to keep going and use negative root 3. So I bring down the 1. I have minus root 3. Gives me 2. Minus 2 root 3. And there's my second 0. And what are we looking for here? We're looking for factor each polynomial. Okay, so I'm going to have x minus root 3, x minus a minus root 3, and what's this one? X plus 2. You could, of course, write this as that. Now, I know that some of you are saying, but Mr. Cooper, can't I do this by grouping? Sure, why not? If the directions specify a method, you must use the method specified. Here I'm taking out an x squared, and I've got x plus 2, and here I take out a minus 3, and an x plus 2. And one of the things I notice is that a lot of people stop here. And we need to stop when we have linear factors, not quadratic factors, only x to the first things. So we're going to have to split this up as x minus root 3 and x plus root 3. Don't forget the x plus 2 here as well. There's our polynomial. We should be able to FOIL this back to the original. So I'll say that this is concerning to me because most people don't go further than that, and I need you to. And second, a lot of people get very tense about trying to go further from here to this place. I mean, really all I'm doing is setting this equal to 0 and then taking the square root of both sides. But for whatever reason, I see that people really struggle going from here to here. So, I'd think about doing the synthetic division, especially if the problem says use synthetic division. Okay, part B, we've got 1 plus root 3, and we're dividing into minus 3 and 2. Did you see the 0 placeholder? Look, there's no x to the firsts in this problem. And if you don't have that 0 placeholder, you might as well not do the problem because you're going to get it wrong. Bring down the 1, distribute the 1 to those, add negative 2 plus root 3. Well, now I have to take this and multiply it by this. And we call that FOILing. So I've got negative 2 minus 2 root 3 plus positive root 3 plus 3, because root 3 times root 3 is 3. I can combine like terms and get 1 minus root 3. So that's what I put here, 1 minus root 3. I add, I get 1 minus root 3. Now I've got to FOIL this with this. Hey, that looks a lot like a difference of squares, doesn't it? 1 plus root 3 times 1 minus root 3. So yes, this is a difference of squares. We're going to have that plus root 3, that minus root 3, and then root 3 times root 3 is 3. So here I get negative 2, and the middle terms cancel. And that gives us a nice 0, just like what we want. Don't forget now, we need to use the conjugate. So 1 minus root 3. I bring down my 1, I distribute, I get those canceling, and I have negative 1, and I distribute, minus 1 plus root 3, I add, I get 0. So our completely factored form, x minus 1, that's this piece. Now I want x minus all this stuff. X minus, 1 minus root 3, and x minus 1 plus root 3. I don't particularly need you to distribute these negatives. You're more than welcome to if you want. All right, so let's look at part C here. Part C says that we're given that negative 1 is a root. So I know negative 1, 1, 1, negative 3, negative 5, negative 2, 1, negative 1, 0, 0, negative 3, 3, negative 2, 2, 0. Now the funny thing about this is I can't factor that by grouping. We started with an x to the fourth, we divided by x, so now we have x to the third minus 3x minus 2. I don't know how that factors. So what is it that we're supposed to do? Well, we can try one of two things. We can try graphing and reading one of the x-intercepts there off the graph. We could also think about using this number again. Why? Well, what if this has a multiplicity of 2, or even a multiplicity of 3, so that you have a bounce or a wiggle on the graph at x equals negative 1? So let's test. If I divide negative 1 in a second time, and I get a remainder of 0, then yeah, why not? Negative 1, negative 1, 1, negative 2. Look at that. And now I've got something that I can factor. That's going to factor as x minus 2, x plus 1. Don't forget these, x minus a minus 1, and that one, x minus a minus 1. Whoa, that's going to be x plus 1, and x plus 1, and x plus 1. So we do have a wiggle there, and we've got that x minus 2 out in front. Okie doke. There's station 3. How about station 4? Graph the polynomial by using x and y intercepts and multiplicity. All right, so station 4, we've got y equals x minus 3 to the third, x plus 4 squared, x plus 1. So I see that I have negative 4, negative 1, positive 3, because inside is opposite land. 3 plus 2 plus 1 is going to be 6, so I know both ends go up. I don't see any negatives in here to worry about this as a negative leading coefficient, which is why I just went right ahead with both ends go up. Okay, and what's happening at negative 4 is a bounce. Whee! And at 1, we pass through, and at 3, we wiggle. Again, your wiggle is going to look like this. Uh-oh, I can't connect that with that. Or it's going to look like a positive x to the third. Okay, let's put in our y-intercept as well. Our y-intercept is found by plugging in a 0 here, a 0 here, and a 0 here. So we're going to have negative 3 to the third. We're going to have 4 squared and positive 1. So that's negative times negative times negative, which is negative 27 times 16. 27 times 16 turns out to be 432. So we've got negative 432. Any questions about that? Okay. Now, what about the second graph here? Well, the second graph says that y equals x minus 3 squared, x plus 4 squared, and x plus 1. Well, now we have a 2, 4, 5 fifth degree polynomial with a positive leading coefficient. There's negative 4, there's negative 1, there's 3. At negative 4, I'm bouncing, but remember, because I have an odd degree polynomial with a positive leading coefficient, I've got to start with this, and then bounce off at negative 4, pass through at 1, and bounce on 3. My y-intercept, what I get from plugging 0 in for all these x's, is going to be negative, no it isn't, that's a squared, it's going to be positive 9 times 16 times 1, which is 144. Okie dokie, that was station 4. Let's take a look at station 5. Station 5 says graph the parabolas labeling 3 points, x and y intercepts, as well as vertex are good points in general to work with. Alright, well let's see what our first one is. Ooh, it's in vertex form. So remember vertex form, y equals x minus h squared plus k. I can see my vertex is going to be located at negative 1, positive 4. And what else do I know? Well, I know that if I plug in x equals 0, I'll find a y-intercept. So 0 plus 1 is 1. 1 squared is 1. 1 times negative 3 is negative 3. And negative 3 plus 4 is 1. So 0, 1 is my y-intercept. This parabola points down, and this is the vertex. So we've got a down-pointing parabola. We've got the point negative 1, 4. Then to the right of it, we have 0, 1. And let's use symmetry to figure out where this point is. This point over here is going to have the same y value as this point. But look, the distance from here to here was minus 1. To go from 0 to minus 1 is minus 1. And since this is halfway in between these 2 points, I'm going to have to go another negative 1 over. So minus 1 is minus 2. Okay, here's the first one, vertex form. Second one is general form. Y equals 2x squared minus 8x plus 7. And in general form, we said that we would want to use x equals minus b over 2a. And so our b is negative 8, so minus a minus 8 over 2 times 2. Our a value is 2. So I get 8 over 4, or 2. So 2 is the x-coordinate of the vertex. I wonder what the y-coordinate of the vertex is. I'm going to use synthetic substitution to find out. 2, 4, negative 4, negative 8, negative 1. Excellent. So I know my vertex is located at 2, negative 1. It's an up-pointing parabola whose y-intercept is 7. So let's graph what we know. This point here is 2, negative 1. This point is 0, 7. If I use symmetry, this distance is 2, so this distance must be 2, so this must be 4, 7. Okie doke. And the last one we have is given to us in intercept form. Hey, remember, if any of these problems that I do turn out to be things you're not comfortable with, you're not sure of, wow, I went really fast, and going back and watching it again isn't helping, don't forget to reach out while you're watching. At the very least, ask me in the next day's synchronous Zoom class, and we'll go over the stuff. Here, this is intercept form. I see some factors, so I know my x-intercepts are 5 and negative 1, because inside is opposite land. So if I plot those, and it's positive 4 times positive x times positive, means my parabola opens up. So what do I know? Well, I've got -4, I got +5. These are x-intercepts, and I have a choice as to whether I want to find the vertex or the y-intercept. I myself like the y-intercept because I'm just going to cover these up and say 1 times -5 is -5, and -5 times 4 is -20. So this is 0, -20. But if you felt really passionate about it, you could find this vertex. And we know that the x-coordinate of the vertex is halfway between those x-intercepts. So -1 plus 5 divided by 2 is 4/2, or 2. We know the x value here is 2. Now, I could FOIL this out, distribute, and then use synthetic substitution, or then plug the 2 in for all the x's, but I'm just going to plug the 2 in. 2 plus 1 is 3. 2 minus 5 is -3. -3 times +3 is -9. -9 times 4 is -36. Whoa, way lower than that y-intercept. Okay, so yes, you need to be comfortable with all 3 of these for our polynomials test. Also, our final exam for the semester, our final exam is actually going to have a whole day that's just graphing. It comes in 2 days. So let's make sure we're comfortable with graphing. Station 6 talks about simplifying complex number expressions. In number 1, we have 6 plus 5i. Nope, that's the next one. Minus 3 minus 2i. Okay, so I'm going to distribute this negative. 6 plus 5i minus 3 minus a minus is plus 2i. 6 minus 3 is 3. 5i plus 2i is 7i. Done. In problem number 2, we've got 2 plus 3i over 3 minus 2i. And so when we did these, we said in order to get rid of that radical in the denominator, we were going to need to multiply by the conjugate. Remember, when we multiply by the conjugate, we're only changing the interior sign. This isn't like making the positive and negative components for absolute value equations that we did in the Algebra Basics unit. Here, we're just going to flip the interior sign. We do not want -3 plus 2i. No, 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 no. All right, so what do we get? Well, if I FOIL on top, I get 2 times 3 for 6, plus 4i, plus 9i, plus 6i squared. And on the bottom, I get 9 minus 6i, plus 6i, minus 4i squared. Well, how does that tidy up? Well, 4i plus 9i is 13i, and I squared is -1. -1 times 6 is -6. Ooh, look, those cancel. On the bottom, these are opposites, and they cancel. I squared is -1. -1 times -4 is +4, plus 9 is 13. How convenient. We end up with our answer being I. Okay, the last problem on station 6 is FOILing, and 3 minus 2i. So I'm going to have 18, it's 15i, minus 12i, minus 10i squared. It's going to be 18 plus 3i. I squared is -1. -1 times -10 is +10. So how about 28 plus 3i as our answer to number 3? Station 7. Ooh, 4 problems, and they're write the equation of the graph. That's very interesting. 2 quadratics and 2 higher degree polynomials. So for A, I see this kind of thing happening. This point is given as -2, this one is 3, and 0, 12. Okay, well, first thing I notice is I've got a bounce. Second thing I notice is I got a negative leading coefficient. And third, I've got an odd degree polynomial. So let's start with x minus a minus 2, which could be written as x plus 2. But because of the bounce, we want a square. I see I pass through at 3 as well. And that's feeling pretty good. But, I don't know, how do I get that a value? Don't forget to find your a value. So I'm going to plug in that ordered pair 0, 12. 12 equals a. 0 plus 2 squared. 0 minus 3. And let's see what happens. 12 equals a times 4 times negative 3. Well, that's negative 12a equals 12. And so a must equal negative 1. We need to plug that negative 1 in there. Y equals negative x plus 2 squared, x minus 3. Okay? Okay. Second problem, part B. B gives me a wiggle, a bounce, and a pass-through. And a y-intercept 0, 5, 40. This point is located at 2, this is negative 3, and this is 5. And these are our x-intercepts. Well, because of the wiggle there, I know I've got x plus 3 times. Because of the bounce there, I have x minus 2 twice. And I just passed through here for x minus 5. Don't forget that a. You still need to plug in that ordered pair for x and y and solve for that a. 540 equals a. 0 plus 3 is going to be 3 to the third is 27. 0 minus 2 is negative 2. Negative 2 squared is 4. And 0 minus 5 is negative 5. Well, that's pretty convenient. Negative 20 times 27, I think that's 540. Negative 540. 27 times 20. Why, yes it is. So I have negative 540a equals 540. And when we divide both sides by negative 540, positive divided by negative is going to tell us that a equals negative 1. Again, we're not quite done yet. We need to take this a value and plug it back in here. So negative 1, x plus 3 to the third, x minus 2 squared, and x minus 5. And that takes care of our end behavior. You know, we've got both sides going down. We just want to make sure that when we're done with the problem, that it actually matches what we expected. A wiggle at negative 3, a bounce at positive 2, passing through at 5. And this helps us get that y-intercept there. All right, but then we'll go even further back to the second day of this unit, and it's when we were talking about going backwards with quadratics. This is negative 3, this is 7, and this is the point 0, 6. Well, since I'm given the two x-intercepts, I think about using intercept form. So I'm going to plug my x-intercepts in for b and c, minus a minus 3, x minus 7. Okay, and luckily we have another point that we can plug in for x and y to solve for a. So I get a equals 6 over negative 21. I can divide 3 out, and so I get an a value of negative 2 sevenths. Great, so then our equation y equals negative 2 sevenths, x plus 3, x minus 7. 21 goes down here, divide. Oh, I feel pretty good about that. And then the last one, d here, we've got an up-pointing parabola with the vertex at 1, 5, and the y-intercept at 0. Is that 0, 10? That's 0, 10. So, can we do this? Of course, we're just going to use intercept form. Vertex form. HK is our vertex, so I'm going to plug a 1 here and a 5 here. Now, I'm going to use my second point to help me solve for a. Don't put the 0 here and the 10 here. This is the x value, this is the y value. 10 equals a. 0 minus 1 is negative 1. Negative 1 squared is 1. And plus 5. If I subtract 5 from both sides, I see that a equals 5. Remember, you're not done until you take that a value and plug this back in. Plus 5, there's a 5 there, yes, yes. Okay, so that was station 7, a bunch of going backwards problems. Station 8. Describe the end behavior of each function using appropriate notation. And remember, we talked about having this little graphic organizer, which had even or odd degree. And then we had positive leading coefficient or negative leading coefficient. Even degree polynomial with positive leading coefficient, we know both ends go up. Even with a negative, both ends go down. Odd with a positive, this is down, this is up. And odd with a negative, this is up, this is down. But notice how it said appropriate notation there. So what I'm looking for is as x heads to infinity, f of x heads to infinity. Infinity. That's this. As I go this way, as x heads towards infinity, where are the y values going? They're heading up to infinity. So if I wanted to describe this, I'd say as x heads to negative infinity, so we go in this direction, f of x is also headed towards infinity. So this is the appropriate notation I'm talking about. Yes, you will see that on the test. Yes, you do need to do that. And so please ask questions if you have them. So let's look at our functions. Number 1, f of x equals negative 3x to the 5th. Odd, negative leading coefficient with an odd degree. I know that means this is up and this is down. So I'm going to say as x heads to infinity, f of x is headed to negative infinity. And as x heads to negative infinity, as we go this way, it looks to me like this function is headed up. F of x heads to positive infinity. There's our appropriate end behavior notation. 2. G of x is given to us as 4x to the 3rd plus 2x minus 1. Positive leading coefficient, odd degree polynomial. So that's going to be going up over here and down over here. So we'll say as x heads to infinity, f of x heads to infinity. And as x heads to negative infinity, as we go this way, where's the function going? Down. Negative infinity. Problem 3 is an even degree polynomial with a negative leading coefficient. H of x is negative 1/2 x squared, no, x to the 4th, plus 2x minus 7. Even degree, negative leading coefficient. That means both ends are going down. So as x heads to infinity, f of x heads to negative infinity, because we're going down. And as x heads towards negative infinity, as I go this way, the function is still going down towards negative infinity. Okay, the last one is positive x squared with a positive leading coefficient. And so what's going to change? That. This is my answer for part for number 4. All right, that was station 8. And we've got how many here? 15. Let's go. We passed halfway already. Number 9. Station 9. Catapult hits its vertex at 4860. So we've got this catapult, and it's firing, and we're saying this is 4860. Okay, and this is where you fire the catapult from. This is 0, 0. Where should you position your catapult in order to hit a target on the way down so that this is 24? And notice how it says, where do I position my catapult? Well, I want to know what that x value is, because I want this to be my where I position my catapult. So let's start by writing the equation of this parabola. We're given vertex form, so I'm going to start with vertex form. There's my vertex. And up, I have a second ordered pair to help me find A. 0 equals A. 0 minus 48 is negative 48. And 48 squared is going to be 2304 plus 60. Now, I can't add these. This does not have an A. This does have an A. I can subtract 60. And then divide by 23/4. Okay, so there's my A value. So my equation, negative 60, 2304, x minus 48 squared plus 60. Now, this 24, this is an output. It's not an input. I'm asked to find the input. The output is 24, so I'm going to plug in a 24 here and solve for x. I'm going to subtract 60. I'm going to multiply both sides by the reciprocal. I'm going to take the square root, and I'm not going to forget the plus and minus, and then I'm going to add 48. Wow, that seems like a lot of work. Or I can graph this in y1 and this in y2, and I could do second calculate answer. So I think actually I was about to do it with the calculator, but I realized what might be more intimidating would be to try and do this by hand. So I'm going to do it that way. I'm subtracting 60 first. So I get negative 36 equals negative 60 over 2304 x minus 48 squared. Great. Now, I mentioned that I wanted to multiply both sides by 2304 and divide by 60. Negative 60. 2304 and negative 60. That way these cancel and these cancel. I think there's some tidying I can do here. I know that 6 goes into both of these. Ooh, 12 goes into both of these. 12 goes into this 3 times, and 12 goes into that 5 times. And yes, negative divided by negative cancel as well. So that's x minus 48 squared. Well, now I've got to take the square root. 69, 12 divided by 5. Don't forget that plus and minus. X minus 48. I'm wondering if, I know this isn't going to be divisible by 5, but just idly curious, is there a whole number value for the square root of 69, 12? And I get, no, 83.1384. I'm sorry, 1384. So, yeah, I'm not going to worry. I'm just going to add 48. And so my answer is looking like 48 plus or minus square root of 6912 over 5. That's what x equals. However, I don't want to know the first time we get to 24. I want to know the second time we get to 24. So I don't want the minus. I only want the plus. You can't give both answers here because the problem explicitly said on the way down we should hit that point. So we can only have the plus version. Okay? Second question. A badminton shuttlecock flies from my racket according to the curve h of x equals negative 0.94285x squared plus 21.0857x minus 44.57142. All right. Will my serve go over the 70-inch net? Well, this is a parabola that opens down. And where's that? Well, I want to know if the 70-inch net is here, in which case, no, the shuttlecock does not go over the net. Or if 70 is here, oh, that volleyball experience where we just clip the net. Or is 70 inches here, in which case, yeah, I definitely go over that net. So the way we can figure that out is to find out what the y value of the vertex is. Now look, you may want to do minus b over 2a here, but not me. I'm going to type h into y1, and then I'm going to do second calculate maximum. So I've got negative 0.9428 x squared. Is it there? No, nothing's there. Oh my goodness. Negative 0.94285 x squared plus 21.0857 x minus 44.57142. 57142. Good. Now, here's the thing. If I just, do zoom standard, I'm not getting a good sense of this down-pointing parabola. And why? Well, we know the y values we're asking about. Do we get up to 70? So let's change that viewing window. X is a negative number. Yeah, I don't think so. X maximum. Well, based on the fact that we saw 10 and it was just going here and we still had all that way, I think I'm going to go out to 100 in steps of 10. And my y values, well, I don't want any negative heights, but I want to see if it gets to at least 70. So I'm going to put 100 here in steps of 10. So what happens on my calculator? Ooh, I didn't mean to go to 100 for x's. Probably 20 or 30 would be sufficient. Ah, look at that graph. It's a fabulous graph. And so now I'm going to do second, calculate maximum. I want to move my cursor to the left side of the maximum and hit enter, and move past the maximum to the right side of the maximum, hit enter, and enter because I do not want to guess. And I see that this ordered pair is 11.182, comma, and I believe that says 73.317. Okay, well, this number is greater than 70, so yes, we do go over the net. B, will my serve, if not returned, land in 18 feet from the outline? Huh. Well, let's see. It's very interesting. X is in feet. Okay. And H is in inches. 18 feet. Well, 18 is my X value. Oh, so I want to evaluate H of 18. And again, I don't want to take this 18 and plug it into each of those. I've already got the equation here in Y1. If I just go over to my table and type in an 18, I end up with 29.488 inches. So when the line is 18 feet away, this shuttlecock is still almost 30 inches in the air. So here's out at 18 feet. And at that moment, we have a height of 29.488 inches. Well, that's coming down. So sorry, that's landing out. 10. The box problems. You might want to go back and watch Box Trolls again. So remember, girth plus length equals 120. It's not my rule, it's the post office. Go and ask them about it. Okay, so what do we know? We know that girth is 4x, the length is y, and that's got to equal 120. This is our helping equation. We know that because this is a number and not another variable. Now, what is it that we're trying to do? We're trying to build volume in terms of x. Well, if I look at this shape and I think about the volume, I think about x times y, or x squared y. But our volume needs to be in terms of x's, and right now I don't have that. I got this y here that needs to go. That's why I have this helping equation. Y equals 120 minus 4x. Because I can get y alone by subtracting 4x from each side. now I know what y is in terms of x's. I can replace y with this x stuff. So that's part A. Find v as a function of x. We could even graph this, couldn't we? We have an x-intercept at 0, with a bounce, and an x-intercept at 30. Please note, x squared times negative 4x is going to be negative 4x to the third. Negative leading coefficient, odd degree polynomial. I'm up here and down here. Don't forget the bounce at 0. So this is what my graph looks like. Here's volume, here's x's. So, part B says, what's the domain? Well, in order to find domain, I have to figure out what I can't have. Volume is negative for all these x values, so that's no good. Can't have a negative volume. I also can't have a negative side length, so all this has to go too. So our domain, i.e. part B, goes from 0 to 30. For me, getting a box with a volume of 0, I don't really want that to happen to me. So I'm not making these brackets. But if you're okay with a box volume of 0, put brackets there. Part C, the dimensions of the box with the maximum volume. Well, there's my maximum volume. And this is going to give me the x value that produces the maximum volume. It is not going to be 0 to 30 halfway x equals 15. Okay? This isn't a parabola. So let's go back to our calculator and let's type in that x squared 120 minus 4x. Okay? Now we know that's 30. So when I go to my window here, I kind of want 0 to 30. Now, how high up? Well, this is a cubic function. 30 times 30 times 30 is 27,000. Really? It could be that high? It probably isn't, but you know what? I'm going to go with 30,000 as my first bet. And I'll go in steps of 2,000. Graph. You know, it's a pretty good graph with 30,000. And second, calculate maximum. Okay, I want to be on the left side of the vertex, hit enter. I want to be on the right side of the vertex, hit enter. No, I do not want to guess, so I hit enter. And I end up with 20. Yeah, I can't actually read that. Hold on. He's very dark. LED. Talk to me, LED. Oh, 10. 10 comma 16,000. Now, it's important when you read that 10 comma 16,000 that you don't say that the dimensions are 10 by 10 by 16,000. Remember, the inputs here are x's, 10. Oh yeah, that wasn't halfway in between. And the output is volume. When I'm looking for the dimensions of this box, I'm supposed to say what these are and what that is. Okay, so we know the x's are 10s. We've got 10, we've got 10, and y, oh look, y is equal to 120 minus 4x. 120 minus 4 times 10. 120 minus 40 is 80. And so my dimensions will be 10 inches by 10 inches by 80 inches. Okie doke. Okie doke. Not the 16,000. If the question had said, what is the volume, the biggest volume we can have, that's when I want to use that 16,000 number. Otherwise, that 10 is what I'm looking for. I'm looking for the value of x. The value of x was 10. Station 11. Ooh, look, another word problem. A textile manufacturer's daily production costs are modeled by C of x equals 1, 2, 1, 2, 3. Yep. Minus 110x plus 0.045x squared. Okay, it points up. cost in dollars, and this is the number of units produced. Find the minimum daily cost and the number of units needed to produce that in order to make that minimum cost. Well, because this is an up-pointing parabola, is this our situation? I have a hard time imagining that a cost function will ever be negative, or a cost function would turn out to be exactly zero cost. Yeah, those seem unrealistic to me. So I'm imagining that my graph looks like this, and I'm looking for the minimum cost and the number of units that you need to make. X is number of units, and Y is daily cost. Okay, so it sounds like I'm just looking for that vertex, huh? And again, you could do minus b over 2a. Please, that is not your a value. Your a value is the thing next to the x squared. But then I would just have to take that number and plug it back into this function. So I think I'm going to go over here, and I'm going to put in 1, 2, 3, minus 110x plus 0.45x squared. I don't have a good sense of how far over this is, but I see that y-intercept at 100,000. So, yeah, I don't know. Maybe we'll just leave it on that 30 that we've had for a while. But I'm definitely going to change this to 100,000 in steps of 20,000. Well, that's a parabola, huh? I mean, that's it's looking kind of, yeah, it's a parabola. So I think I want to change my window a little bit. I want a lot more x. Steps of 4. Does that help? Oh, look! It goes up. I didn't need all of this. Okay. So let's change 2,000 to be 400. Steps of 50. Well, that's better. I see a vertex kind of there. I think I'm going to change my y's and go up to 150,000. Well, that's better. I see some sort of vertexy thing there. So I can calculate minimum. Move my cursor to the left. Yeah, I don't know where the minimum is in here. Maybe it's here, maybe it's there, maybe it's a little over here. But I can definitely see I'm going down from here. So enter. And if I had more y value, it might be easier for me to see where the vertex is in here. Enter, enter. And so I end up with 1, 2, 2. I end up with 122.222. 2, comma 93277.77. Okay, so that's the minimum daily cost, $93,277.77. And I need to produce 122, and as I'm making the 123rd one, that's when I reach my minimum cost. So ideally, I only make 122 each day. Okay, that's part A. Part B, what is the cost if no units are produced? Well, remember, x is the number of units produced, and if we turn these into zeros, oh, our y-intercept. That's right. We're going to have a cost of 100,000 even if we don't make any. In fact, our cost goes down by making some of these things. So, yeah, business. It's interesting. Okay, that was station 11. Station 12, graph each polynomial. So with station 12, I've got 3x to the third plus 10x squared plus 4x minus 8. That looks like a prime candidate for factoring by grouping, and I'd end up with x minus 2. But that's not going to get x minus 2, so no, not using that. I can't use factor by grouping. There was an old school technique, but we're not doing that anymore. Instead, we're supposed to take out that calculator and graph 3x to the third plus 10x squared plus 4x minus 8. I'm going to go back to the standard window, zoom standard, and see what happens. So, yeah, I got something in there, maybe. It's really hard to tell. What if we do -1 to 1? I kind of wondered if I type that in right. 3x to the third plus 10x squared plus 4x and minus 8. And what's all this gobbledygook after that? There we go. Oh, look at that. So maybe there's an x-intercept over there. I wish I hadn't done changed those x values. Ooh, a bounce. Is that at -2? Let's see. I'll plug in a -2. I get a 0. Yes. And a bounce means I've got a double root there. So -2, 3, 10, 4, -8, -6, 4, -8, -4, 8, 0. And because of the bounce, let's do it again. 3, -6, -2, 4, 0. So this is 3x minus 2. And we had that x plus 2, right, minus a minus squared. Was I supposed to, graph the polynomial? Can do. So, I see that I have my bounce at -2. And passing through at 2/3. Don't forget to label the y-intercept. That value at the end there with no x's is always for a polynomial, my y-intercept. Well, there's part A. What about part B? I feel like we saw this one earlier in the stations. F of x equals x to the third minus x plus 6. I think I mentioned this when we were talking about zero placeholders. So let's see what we get. We've got x to the third minus x plus 6. And graph. Well, it looks again like -2 is an x-intercept, but no bounce, no wiggle, no others. I got some imaginaries coming my way. So let's try -2, 1, 0, -1, 6. Don't tell me you forgot already. Yeah, this says zero placeholder. Look, there's no x squareds. Nobody's going to tell you that on the test. So you got to write down a note about that. 1, -2, -2, 4, 3, -6, 0. Now, we saw no other real x-intercepts. And so what does that mean? That means that that puppy is not factoring. Look, you could factor it as x minus 1 and x minus 3. Minus times minus is plus, that's great, but now you've got minus 4x instead of minus 2x. No. So what do we have to do? That's right. We have to use the quadratic formula. X equals -b plus or minus square root squared minus 4ac all over 2a. So that's going to be 2 plus and minus square root 2 squared is 4 minus 4 times 1 times 3. That's going to be minus 12 over 2 times 1 over 2. So now we're going to have 2 plus and minus square root of 8 over 2. Don't cancel those. 2 plus and minus 2 root 2 over 2. Well, here I can take a 2 out of each of the terms on top. And so that's going to give me 2, 1 plus or minus root 2 over 2. And now I can cancel. Wait. That's -8. That's 2i root 2. So we need an I there. Yeah, definitely need it to be imaginary and not real. So what are we looking for? A graph. Well, so here's the thing with our graph. I got only the one real x-intercept, and that's at -2, and we have 0, 6. I know it's a third-degree polynomial with a positive leading coefficient, so it's down on this end and up on this end, and so I'm going like that. Now that's not actually what it looked like, was it? Right? If ours had that little wee. And if this were honors pre-cal, we would actually talk about how you could graph that little wheedle dance going on there, but it isn't. But if you're interested in learning about it, come into office hours sometime and say, hey, how do I graph when I have imaginary roots? Okay, see, f of x here is -4, x minus 1 to the third, x plus 2. All right, well, we're almost done. This is station 12 of 15, so just hang on a little bit longer. -2, +1. I got a wiggle at 1, and I pass through at -2. It's a fourth degree polynomial with a negative leading coefficient, so both ends go down. I'm going to pass through -2, and I'm going to wiggle at 1. Don't forget to label the y-intercept by plugging in a 0 and a 0. -1 times -1 times -1 is -1, times 2 is -2, times -4 is +8. And there's our graph. All right, station 13. Let's see. Ooh, if 3 plus I is a 0, find the remaining zeros. Notice how it doesn't say find all the zeros? It says find the remaining zeros. Well, let's see how that goes. 3 plus I, 1 minus 4 minus 2, 20. Bring down the 1, and get 3 plus I add -1 plus I. Uh-oh, it's foiling time. 3 plus I minus 1 plus I. It's -3 minus I plus 3I plus I squared. I squared is -1 plus -3 is -4, and 3I minus I is 2I. Well, that's interesting. So -2 minus 4 is -6. And so now again I have to take this and FOIL it with that. 3 plus I times -6 plus 2I. Now look, if this is a 0, I gotta end up with a 0 here, which means this has to be -20. I just want to make sure, because if it turns out this isn't -20, then there's a mistake in here, and then the next step won't work. So why waste the time pretending it does work when it doesn't? So let's do some FOILing. We've got -18 minus 6I plus 6I plus 2I squared. Okay, so the middle terms cancel. I squared is -1 times 2 is -2 plus -18 is in fact -20, and I do get that 0. Now I need to use the conjugate. 3 minus I. 1, 3 minus I. It's going to be +2, and then I multiply and I have 6 minus 2I, and when I add I get 0. So it looks like x plus 2 is a factor, but in this problem I'm looking for zeros, not factors. So x equals -2, and don't forget x equals 3 minus I. Those are our two remaining zeros. Don't give me all three. The remaining zeros. I gave you one of them, so you give me the others when I say remaining. Okay, let's take a look at number 2 here, where we've got 2 minus 5I, 4, -19, so don't write -18, 128, and -87. 4, 8 minus 20I, -11 minus 20I. Now I've got to FOIL this with this. 2 minus 5I, -11 minus 20I. So it's going to be negative 22 plus 55i minus 40i. That's going to be 100 plus 100i squared. Well, I squared is negative 1. Negative 1 times 100 is negative 100 plus negative 22, so negative 122. And then here, when I combine my terms, I get 15i. Again, when I add these and get 6 plus 15i, I know that when I FOIL this times this, I'm supposed to get positive 87, so I can get a 0 here. Let's see if that's what happens. 2 minus 5i times 6 plus 15i. 12 minus 30i plus 30i minus 75i squared. Well, I squared is negative 1 times negative 75 is positive 75 plus 12 is 87. Middle terms cancel. And so, yep, I get a 0 remainder. That's great. Now I can use the conjugate. 2 plus 5i. 4, 8 plus 20i minus 3, negative 6 minus 15i, and 0. So we're asked for the remaining zeros. Well, I don't want the factor. I want the 0. I also need that one. That's a remaining 0. It only gave me this one. These are the remaining zeros. X equals 2 plus 5i. Okay, that was station 13. We've only got 2 left. I hope this is helping you. Station 14 says find all the roots. And for A, our f of x is given as 2x to the third minus x squared minus 6x plus 3. And I can do factoring by grouping here. Watch those signs. Remember, these have to be the same. Because they're the same, I can pull them out, and I'm left with x squared minus 3. Hey, don't stop here. Remember, we need to find all the roots. So either you need to factor this as a difference of squares, which would be x minus root 3, x plus root 3, times 2x minus 1. And so now you can say, all right, x equals plus and minus root 3, and x equals 1/2. Or you could take this x squared minus 3 and set it equal to 0. And when we take the square root of both sides, we get plus and minus root 3. So we can get those roots. Find all the roots. There's all the roots. Look, it's a third-degree polynomial. If I don't have 3 roots here, I'm in trouble. All right, B. Can I do B factoring by grouping? Let's take a look. X to the third minus 2x squared minus 5x plus 6. So, can you factor that by grouping? Ooh, let's get that glare out of there. All right, and the answer is, that's a little blurry now. That's better. No, I can't. So I'm going to pull out my calculator, and I'm going to graph x to the third minus 2x squared minus 5x plus 6, and see when I do zoom standard if I can see one of the x-intercepts. Negative 2, positive 1. Let's go with positive 1. 1, negative 2, negative 5, 6. 1, negative 1, negative 1, negative 6. Great. So this is x squared minus 1x minus 6. And that's going to factor as x minus 3, x plus 2, and don't forget x minus 1. Find all the roots, 1, 3, negative 2. Okay, it's nice when we have a little seed to start our synthetic division with. And then this last one, it looks like another factor by grouping, x to the third minus 3x squared plus 4x minus 12. So I can take out an x squared here, and I'm left with x minus 3. Here I can take out a positive 4 and be left with x minus 3. Get x squared plus 4 times x minus 3. So where are my roots? Well, x equals 3, but what about here? You know, a lot of people say plus and minus 2, but let's actually take the time to see that I'm now taking the square root of a negative number. So I'm going to have plus and minus 2i. So those are my roots, x equals 3 and plus and minus 2i. That was station 14. Let's take a look at our last station, station 15. And this one says completely factor each given polynomial. And a is 4x to the third minus 3x minus 1. Are you saying zero placeholder yet? You should be. So what am I going to start my division with? Well, let's put in a 4 here. And let's get rid of all of that. I have minus 3x. And then a minus 1. And well, it looks like positive 1 for 0 placeholder minus 3 minus 1. 4, 4, 4, 4, 1, 1, 0. Cool. And so what's that? Well, that's 4x squared plus 4x plus 1. And yes, that's a perfect squared trinomial. And if you want, yeah, I mean, it says completely factor. So I myself I'm going to stop here. Don't forget that, right? If you just put this as your answer, is this going to get you the x squared that you started at the x to the third you started with? No, this is only going to get you x squared. You have to have completely factored x times x for x third. Okay? Or you could write x minus 1 times 2x plus 1 squared. Because there's a bounce at negative 1/2. All right, what about B? B looks like I might be able to use parallel structure, but maybe not. Let's see. 4x squared minus 45. You know, I think so. This looks a lot to me like this problem. And this could be x plus 9, x minus 5. See how this comes here and here? So if I use parallel structure, this is going to come here and here with the same plus 9 and minus 5. Now it does say completely factored here, and that means I want only linear factors. So if x squared plus 9 has to equal 0, then x squared equals negative 9, and x equals plus and minus 3i. And here, if x squared minus 5 equals 0, then x squared equals 5. And when I take the square root of both sides, x equals plus and minus root 5. This is not done. We are looking for factors. You have not finished until you write x minus 3i, x plus 3i, x minus root 5, and x plus root 5. Okay? Completely factored with linear factors. We only want linear factors at this point in the year. And our very last problem on the stations, f of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. Yeah, no idea how to factor that, so I'm going right over to the calculator. X to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. Graph. Negative 2, positive 3. Let's see what happens. Negative 2. 1, negative 3, 6, 2, negative 60. 1, negative 2, 5, 10, 16, negative 32, negative 30, positive 60. Oh, nice. This is going to be x to the third minus 5x squared plus 16x minus 30, and that is not factoring by grouping. There's nothing I can take out of both of these that's going to get me a 1 and a 5. So, what was the other one that I thought I saw? I wondered if positive 3 would work. 1, 3, negative 2, negative 6, 10, 30, 0. Ta-da! But what about this? This is x squared minus 2x plus 10. And you know what I know? That These both have to be minus because this is a minus and this is a plus. If I do that, does that get me negative 2? No, that gets me negative 11. What if I do? No, that gets me negative 7. So, yeah, this doesn't factor, which means I have to use the quadratic formula, squared minus 2x plus 10, to find these last two factors. Okay, so minus b plus or minus square root b squared minus 4ac all over 2a. So that's 2 plus and minus. 4 minus 40 is negative 36. Oh, 2 plus and minus 6i over 2. Do not cancel those. Listen, pay attention. Oh my goodness, stop it with that. I can take a 2 out of the top and have 1 plus and minus 3i over 2 and then cancel. I can cancel a 2, and a 2, but I can never cancel just like that. Okay? Okay, so these are zeros. And where were my other zeros? My other zeros were x equals negative 2 and x equals 3. So my factored form, x minus 3, x plus 2, because remember, inside is opposite line. And now these, x minus 1 plus 3i, and times x minus 1 minus 3i. And again, you don't need to distribute. Okay, well, I hope this was helpful. And I wish you great success on your polynomials test. Take care, everyone.